Hello, everyone. Today is an exciting day because we are going to start talking about Unit 2. So we're going to do a little bit of an introduction today. And then on Monday, when I get back, we're going to kind of recap some of what we talked about today. Okay. But a couple of reminders before we get started. If you guys have not taken the Unit 1 test, make sure you email me today. And we can start planning out a time for any of you guys that didn't take it to actually make that up. Okay. So if you know you're one of those students, make sure you send me an email by the end of the day today. Okay. In your workbooks, though, please make sure you turn to page 130. We are going to start with the example at the top of the page. Now, Unit 2, what is Unit 2 all about? Now, Unit 2 is definitely different from statistics in a lot of different regards. But Unit 2 specifically, it really goes into the relationship between a lot of what you see here. We're going to look at equations, we're going to look at some inequalities, and eventually we're going to get towards the end of this unit, we're going to look at systems. So for today specifically, we're going to start to just investigate what are some of the relationships about variables, numbers, and what do they mean in relationship to an equation, okay? So if you look at the top of the page here, I'm going to give a couple of reminders actually before we get going. And that is, especially since this is our first video, keep in mind that you can always pause your video. If I'm going too fast, or if you need a moment to kind of write down what I have on the screen, please feel free to pause the video. Plus, if you have any questions, you can write these in your workbook. And these are questions that I will make sure I'll ask about on Monday as well. Okay. But page 130 at the top of the page, it says, first example, here are some letters and what they represent. All costs are in dollars. So all of these guys, M, N, S, and T, because they're representing something in real life, those are all perfect examples of what we call variables, okay? Variables are simply just letters we give to represent things that we don't know in real life. So for example, we don't actually know the cost of a main dish, which is why we're going to let M represent that cost, okay? So if you look at question one says, discuss with a partner, what does each equation mean in this situation? Now, you guys do not have to discuss this with a partner necessarily, but I do want you to take a moment and kind of think about what each of these mean. Like, for example, if we look at 1A, it says M equals $7.50. Now, when I read this, because M is the variable that's involved, it's really telling me that M, since that's the cost of a main dish, says M equals $7.50. And in my mind, what that's really telling me, it's saying a main dish costs $7.50. That equals sign in here does something pretty specific. Equals in real life really just means is. So it's saying a main dish is $7.50. Now, what I want you to do, not necessarily with a partner, but just on your own, I want you to work through and answer questions B, C, and D. I want you to think about what each of those equations could possibly mean and write down what you're thinking. So take a moment here, please, and pause your video and try examples B, C, and D. Now, you do not have to have the exact same answers that I have, but for part B here, if it says M equals S plus 4.50, really this is telling me we're still working with our main dishes. Now, the equal sign tells us that a main dish is or costs $4.50 more than a side. If we're adding 450 and S together, that's exactly what it's telling us. Part C says ordering N side dishes costs $6. If you're going to calculate the price of something, we use multiplication to do that. We take the item itself, the cost of something, and we multiply it by the number of those items that we have. And in this case, it's telling us that the total price of those sides is about $6. Question D here says if I take M plus NS equals T, this is really just telling us that if I find the total cost of what this meal was, that we're taking whatever the main dish was and adding to it whatever the cost of your side dishes were. Now, when we look at equations, we're going to kind of look at the relationship between something that is fixed and something that varies. Now, pretty much anything that's fixed in here is something that actually has a number in it. Because those numbers that are here, we can't change what those are in an equation. because that 450, it's saying it is 450. Now, when we start looking at some of the other pieces though, variables by definition are things that can vary. Because they're things that we don't know, we're saying that those variables could equal any number that's out there in the world. Now, we do have to kind of keep in mind that there's some things that can't be true about certain variables. And we're going to look at this a little bit more in depth in just a minute. But when it says part 2, it says write a new equation that could be true in this situation. Now, when I'm looking at this, I can't say for something that would not be true is we can't say m equals 8. Because we already know from up above, it tells us that m is equal to $7.50. You can't just magically change the price of what a main dish costs at wherever this is. Now, could we make some other assumptions? Sure. Could we say if I take the cost of a main dish plus the cost of a side, for example, does that equal a total cost? Yeah, that is something that works. That's a person where they only bought one side essentially. Now, at the end of the day though, now these are not in your book when you see this new screen. We want to kind of think about what some of these pieces are. So for example, for the first bullet point, it says, what is an equation and what does it tell us? Well, an equation here, it's simply just a statement. If you're using equals to compare two things, you're saying that one thing is the same thing as another thing. So if m equals 6, you're saying m is 6. M is equivalent to 6. Now, if we're talking about question B here, where it says, can equations contain only numbers, only letters, or a mix? The answer to this question is yes to all of them. If we're looking at equations in general, you can have equations that are completely variables. You can have equations that are completely numbers. For example, if we're talking about only numbers, if I'm going to say 7 equals 7, that is an equivalent equation here because 7 is the same thing as 7. I could say something along the lines of A plus M equals B. That's an equation that has no numbers in it whatsoever, where everything in this case varies. Now, we have to be careful about the equations that we actually can write because they're not always necessarily going to be true. If we think about the example from the previous page, it says, when might an equation be false? Well, if we look at our previous example, if we're saying that M, the cost of this guy right here, if we're saying the cost of a main dish is equal to a side plus $4.50, well, if we know a main dish costs $7.50, that means in this scenario, a side can only cost a certain amount of money. I can't say that S in this case is $10 because if I take 10 plus 450, then that doesn't actually equal 750 at the end of the day. So there are some cases where equations might be false. And one of those cases that we're going to look at has to do with something called a constraint. And this is on page 132 in your book. And what a constraint is, it's simply just something that limits what is possible or reasonable in a certain scenario. So like, for example, if we were having a pizza party, we could say that one constraint would be that each person can have less than 4 pieces. Now, this symbol right here is something that's going to be pretty helpful for us. When we look at this less than symbol, if you have a symbol that looks like this, now it's not an equal sign, but it is something that we can use to compare 2 pieces. If you have this, the inequality sign that's facing this direction, this is your less than. And if we flip it around, that is our greater. Whoa, sorry guys. So it looks like a cute greater than. All right. So if we put a constraint on a variable, in this case, if we're saying that the number of slices a person can have is less than 4, then you can't say that that person can have 5 pieces of pizza. They can only have less than 4 pieces in that scenario. So we do have to be careful about if there are any constraints on any variables. Although there's not, you'll notice that a lot of times those constraints come into play when we're talking about what's possible for a variable to be. So let's go turn to page 140. And here's where we're actually going to practice writing a couple different equations. So on page 140, the directions say write an equation to represent each situation. So in example 1 here, it says blueberries are $4.99 a pound. And Diego buys B pounds of blueberries and pays $14.95. So one thing that we want to think about in a scenario is what things make sense to go where. Because anything that's in an equation world, we know we're going to have to start with an equal sign. And the question is going to be what's going to go on either side. So the first thing that it says is blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.95. In equation world, one common equation that we're going to write a lot of has to do with the fact that totals almost always are going to go on one side by itself. Because if I know that the total of his order is $14.95, we can actually write an equation that represents what he spent money on. Now, kind of like in our last example, when we were talking about the warm-up, it says if he buys B pounds of blueberries, if we're going to calculate the amount of money that he actually spends, we have to think about what we would do with that $4.99. And B, if I was going to totally figure out how we come up with that total, most of the times when money is involved, it's almost always where we take the price times the number of items. For example, if I know that he bought 1 pound of blueberries, we would take 1 times $4.99, which would make sense because he would only spend $4.99. If Diego buys 2 pounds of blueberries, we would take the $4.99 multiplied by 2, and that would tell us how much you would spend for $2 or 2 pounds of blueberries. So anytime we're calculating a total like this for a specific item, we would take the amount times the number of pounds of blueberries. Now, in this problem, that's where our variable comes into play, because we don't actually know a specific number that actually ends up being the number of pounds that are there. So this part of this equation, though, that's exactly how we would calculate the total. We would take $4.99 times B, and that's going to tell us what the total in this scenario is. So what I want you guys to do is I want you guys to give B and C a try. So pause your video now and give those a shot. All right, answers are up. Now, almost all of these guys, you're going to notice that I gradually started taking out items. I started replacing actual amounts with variables, but it doesn't change how we calculate the total cost. The total cost always is going to go on one side. Doesn't matter necessarily what variable they use, but on the other side, we would take the price times the number of items. Even in part C, I'm going to take the price, which was D dollars a pound, times the number of pounds of blueberries, which was Q, and that should equal the total cost at the end of the day. Now, if we're looking at part D here it says Noah earned N dollars over the summer. Mai earned $275, which is $45 more than what Noah did. So here's the deal. It says Noah earned N dollars over the course of the summer. So if we're going to calculate what Mai actually end up earning, we already know the total for this piece. It says Mai earns $275. Now, what it's equivalent to has to deal with what Noah did. And it says Noah earned N dollars over the summer. And Mai earned $45 more than what Noah did. So if we take the amount that Noah earned and add 45 to it, we should get the amount that Mai actually ended up earning. So in this case, we don't use multiplication to describe what we would do. Here, we just add. We take the amount that Noah earns, add 45 to it, and voila, you have your equation for how much Mai earned. So I want you guys to pause your video, and I want you guys to try writing the equations for E and F. Pause your video now. All right, answers are up. You should have had for E, you should have had N plus 45. And for D, you should have had W plus Y is equal to X. Okay, so if you guys turn now to the next page, page 144, we have one more example today, and then we're going to call it for today. Okay, so this guy, it says the tax on the sale of a car in Michigan is 6%. Now I'm going to pause before I really read the rest of this. because we have to kind of take a brief moment just to talk about how we convert percents to to a decimal. So when we have that 6%, we always think about either, there's kind of two ways to go about this. And one of the ways is you can take that number, oh, that's not what I wanted. And we take the number and we move the decimal place 2 places. So in this case, if that 6 would go to a 0.06 at the end of this. Now, if you wanted to go the mathematical way of doing it, what we're essentially doing is we're taking this number and we're dividing it by 100. That's how you get your percentage on any assessment from the class. So either way, though, whenever we're going to work in equations, we never leave percents as percents. We always convert them to what their decimal actually is. Okay. So in this case, we're looking at a sale of a car. The tax on that car is 6%. And it says at a dealership in Ann Arbor, a car purchase also involves a $120 in miscellaneous charges. So let's read question 1. Let's see what we're working with here. It says there are several quantities in this situation: the car price, the sales tax, miscellaneous charges, and the total price. Write an equation to describe the relationship between all of the quantities. So two things that we know for sure that aren't going to be changing. We know for a fact the sales tax is going to be 6%. We also know that the miscellaneous charges in this, miscellaneous charges are $120 worth. So out of the other pieces, the original car price is something that we don't know, and the total price is something that we don't know. So in an equation, when there's things that we don't know, those are things that we're going to ultimately give a variable to. Now, in our first example, part A, it does actually give us one of those quantities. It says the original car price is $19,500. So if we're going to start writing our equation here, one thing that I know has to be true is we have to calculate the total price of the car. Now, in this example, because we don't know the total price of the car, we're going to leave this piece as a variable. Now, you can use something else other than T. I'm specifically going to use T. And then we want to think about how we would actually calculate the total price of this car. What are some things that we know we have to spend money on? Well, the first thing that we know we have to spend money on is the actual car. If the original car price is $19,500 or $9,500, excuse me, then I know for a fact right now I have to spend that $9,500 on the car. But there's also some other charges that we have to keep in mind. When you buy a car, there, in this case, in this place in Michigan, because there's a 6% tax on car sales, we have to calculate the tax for this car. And the nice part is that to calculate the tax of something, we take whatever the sales tax is and we multiply it by whatever it is, the thing that you're buying. So since we're buying a car and since the car is worth $9,500, we take that sales tax and we multiply it by $9,500. So that right there represents the tax that we're spending on the car. But we still have one other area that we have to actually factor into our total price, and that is the miscellaneous charges. On top of the car, on top of the sales tax, we have to spend $120 in those miscellaneous charges. But what's nice is that right now you have an equation that's going to calculate what you're going to spend in total on this car. Now, even for part B says what happens when the original car price is $14,699. Well, most of my equation isn't really going to stay the same. The main thing that's going to change is the total price of my car that we see here. Instead of being $9,500, it's going to be $14,699. But my sales tax isn't changing, and my miscellaneous charges aren't changing either. The only thing that's really changing in this part of the problem is the price of the car. Now, in part C, we know for a fact that in this case, they actually tell us what the total price is. So that means in this problem, my variable at the very end, it's not a variable. Because I know what the total price is, we can actually go ahead and plug that in. Now let's think about what we don't know in this problem. In this problem, the thing that we don't know is the actual car price. So since we don't know what the car price is in this case, that's now the thing in this problem that we're going to give the variable to. Now you can use any variable. I'm just going to use P that stands for price. And we still calculate the price of this car the same way. We take the sales tax times the price of the car. And then we have to add the miscellaneous charges in on the end. So what I want you guys to do right now is please pause your video, and I want you guys to try example D on your own right now. Pause your video and give it a shot. All right, answer is up. Now in this case, it tells us the original price is P. That means actually almost everything in here actually has to stay a variable. The only thing that's not going to change are the two fixed prices, the miscellaneous charges and the sales tax. Even on question 2, when it's just how would each equation you wrote change if the tax on the car sales is R% and the miscellaneous charges are M dollars. In this case, where we would say that the sales tax would change and that would become the variable. So what you're starting to notice actually is that there are things that vary and there's pieces that stay constant. Things that vary, these are what we're talking about when we come to actual variables. Variables are the things in the problem that because we don't know what they cost, those are the things that are not fixed. We can place most numbers in there and have something and have an equation be true. When we say something is constant, constant would be like in this example, the things that don't change, like the sales tax, for example, or those $120 in miscellaneous charges. No matter what we changed about the problem, those were the numbers that never really changed because the sales tax never changed in Michigan. And at this specific dealership, it's always a flat fee of $120. So in our equations, when we're going to add variables to things, variables should only really go with quantities that are varying, things that we don't know in our problem, basically. Okay. So your homework for today, guys, first of all, we have our cool down, which is in the Unit 2 folder in Schoology. It's the one called Cool Down 2.1, 2.2. And then your homework tonight, I'm splitting it up the 9 problems that you have. There's 5 problems in the 2.1 lesson. So pages 134 through 137. And then you have 4 problems that are from the 2.2 lesson, which is pages 143 all the way to 146. If you guys do have any questions, though, please feel free to reach out. You can always email me and I'll get back to you as soon as I can. Thanks, guys, and have a fantastic weekend.